So, why particle materials obeys Ohm law? We must understand the conduction process at the atomic level. We discuss here. We will only discuss conduction in metals like copper, and we know that the free electron. We can understand this conduction in copper with the help of free electron model, in which we assume that conduction electrons in the metals are free to move throughout the volume of a sample, like the molecules of a gas in a closed container. And we also assume that electrons collide not with one another, but only with the atoms of the metals, like here. The electrons will only collide with the ions of the metal. According to the classical physics, the electrons should have a Maxwellian speed distribution, somewhat like that of the molecules in a gas, and the average electron speed depend on the temperature. So the motion of electrons are not governed by the laws of classical physics. Actually, they are governed by quantum physics. As it turns out, an assumption that is much closer to the quantum reality is that the conduction electrons in a metal move with a single effective speed, V effective, we can say, and this speed is essentially independent of the temperature. For copper, it's around 1.6 into 10 raised to power 6 meter per second. So when an electric field is applied to a sample, the electron modified their random motion slightly and drift very slowly in a direction opposite to that of the field. We discussed this case previously. Here we know that these are the positive charges under the inner conductor, moving in a conductor, and we apply an electric field, and here the negative charges or electrons are moving with some drift velocity and under the influence of electric field. And we know that before applying the electric field, these are moving in a zigzag motion. For example, from an electron is this electron is moving from point P to from point P1 to point P2 with different Coulomb undergoes different Coulombs. And when we apply a electric field, what happens? Electric field drift the electron, and this drift is because of this drift, it covers a distance of Vd into T. So the motion of electrons in electric field is thus a combination of the motion due to random collisions and then due to E. So when we consider all the free electrons, their random motions average to 0 and make no contribution to the drift speed. So thus the drift speed is due only to the effect of the electric field on the electrons. Now, if an electron is placed in an electric field of magnitude E, the electron will experience an acceleration given by Newton's second law, and we know A is equal to F over m and is equal to F over m and is equal to QE is equal to EE over m. So after collision, each electron will completely lose its memory of its previous drift velocity and starting fresh and moving off in a random direction. So in the average time tau between collisions, the average electron will acquire a drift speed of Vd is equal to AT. And moreover, if we measure the drift speeds of all the electrons at any instant, we will find that their average drift speed is also AT. So then this equation of Vd is equal to AT is equal to E T over N. And we can combine these results with current density. We know that VD is equal to J over NE, or J is equal to NE into VD. We have done this before, and this becomes tau over M, and we can also write it E is equal to M over square N tau.